Okay, continuing on to work with more examples of exponents and negative exponents. Again, we're still in Module 5, and we're still talking about negative exponents. And up until now, remember we used the quotient rule. If you remember our quotient rule for division, we said if we had like bases, sum m, b to the m over b to the n, we just take the exponent to the numerator and we subtract the exponent in the denominator, right? So for example, if I had b to the 7th all over b to the 4th, I take b to the 7th minus 4, and I get b cubed, b to the 3rd, right? So we were working with positive exponents there. It's no different if we have negative exponents, right? So if I said simplify x to the negative 4th divided by x to the negative 2, I simply have, I can still use the quotient rule. I have x to the negative 4th minus, right, negative 2, which is the same as x to the negative 4 plus 2, which is x to the negative 2. But again, because we can't leave our answers with negative exponents, I can bring that down to the denominator and make that exponent positive. Okay, let's just do a couple more examples with all of our rules. Let's take, for example, simplify negative 8 w to the 4th u and the whole thing squared. We're going to use the power rule. Right, so remember each one of these has an exponent, right? So I'm going to have to take that 2 and apply it to each one of those exponents. So I have negative 8 squared, w to the 4th squared, u, right, to the 1 squared. So negative 8 times negative 8 is 64. W 4 times 2 is to the 8th. U to the 1 times 2 is squared. Okay, and again, as I pointed out before, note the difference between w to the 4th, w squared, versus w to the 4th, the whole thing squared. Right? This here is going to be w to the 4 plus 2, whereas here it's going to be w to the 4 times 2. Right, so that gives me w to the 6th, whereas this one gives me w to the 8th. Okay, so be very careful about what your problem actually says. Okay, let's do another example. How about this one? Simplify negative 2x over y cubed all to the 5th. Right, so again, remember when we use the power rule, the whole numerator gets that exponent, right, and the whole denominator gets that exponent as well. So this is the same, now this is the same as negative 2 to the 5th. That coefficient gets that power, x gets that power, and this is y to the 3 times 5. Right, so negative 2, if I multiply it by itself 5 times, I get negative 32. It's negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Okay, so that's negative 32, x to the 5th, y to the 15th. let's use an example that uses power and product rules. So if I have simplify, negative 3y squared, negative 3y squared, z squared, this whole thing is squared. And I have x, y cubed, z cubed. Okay, so if I look at just this part, I have to take it and multiply it by itself, each one of these. Right, so I have negative 3 squared, y squared, z squared. Right, I still have x, y cubed, z cubed. If I start simplifying, I get negative 3 times negative 3 gives me positive 9. Y to the 4th, z to the 4th, times x times y cubed times z cubed. And now I'm going to combine everything that has like bases, right? So my 9 stays out here. I have a y to the, actually let's do my x's first. Whoops, that should be a y. Here I have an x, and then I have y to the 4th, y to the 3rd, and I have a z, right, to the 4th, z to the 3rd, z to the 4th, z to the 3rd. So I can simplify that, and I get 9x. That's y to the 4 plus 3, which is y to the 7, z to the 4 plus 3, which is z to the 7. So this one again uses both power and product rules. Of exponents. Okay. Now let's try another one that has some negative exponents. Let's say simplify 4b to the 6th, c to the negative 3, all to the negative 3. So remember, my 4, the coefficient has a exponent of 1. And this negative 3 is going to go to each, it's going to get multiplied to each one of them, right? So I have 4 to the 1 times negative 3 gives me a negative 3. B to the 6 times negative 3. And C to the negative 3 times negative 3. Right? So that gives me 4 to the negative 3, B to the negative 18, and C to the positive 9. And remember, we can't have any negative exponents, so you can think of this as all over 1. So anything that has a negative exponent, you just change places. If it's in the numerator, it goes to the denominator. So I march across my numerator, and I see this, 4 to the negative 3, so that comes down and becomes 4 to the positive 3. B to the negative 18 goes down, becomes B to the positive 18, and C to the positive 9 stays on top because it's fine, it has a positive exponent. Now the only thing I have to remember is 4 cubed. I need to simplify that some more, right? That's the same as 4 times 4 times 4, so that's 64. We're going to have C to the 9, 64, B to the 18. And we're done. Okay, let's do another one. Okay, let's try this one. I'll go here. So simplify. I'm going to have this larger expression here. 2x squared y all over z to the negative 1 all to the negative 3. And I'm going to multiply by x to the negative 3, z to the 6th. Okay, so there's a lot of different ways we can do this, but I'm going to go ahead and rewrite everything using the rules I know. So I have this -3, since I have a quotient, right? This gets divided up like this to the -3 and z to the -1, right? To the -3. And I still have x to the -3, z to the 6th. So again, remember my coefficient has an exponent of 1, so now I'm going to take this exponent and I'm going to multiply it by each one of these. So I have 2 to the 1 times -3 gives me 2 to the -3. X times 2 to the -3, right? Y times 1 to the -3 again. And then down here I have z to the -3. 1 times -3 gives me a +3. And I have x to the -3, z to the +6. Okay, let's keep going. Now remember, this is like over 1, right? So I have 2 to the -3, x to the -6, y to the to the -3, all over z cubed, times x to the -3, z to the +6, all over 1, right? So I'm going to combine what I can on top. So I still have 2 to the -3, x. I'm going to move them closer, right? X to the -6, x to the -3. I have y to the -3, z to the 6th, all over z cubed. So these can combine. So I have 2 to the -3, x to the -9, y to the -3, z to the 6th, all over z cubed. And now let's start marching across to keep our exponents positive, right? So let's see. I had a 2 to the -3, so that goes down here and becomes 2 to the +3. I have an x to the -9, so that goes down, becomes x to the +9. I have y to the -3, so that goes down, becomes y to the +3. And then my z to the 6 stays up, and I have a z to the +3 down here, right? I'm almost done, but not quite, because if I look, I still have the same, I have a base in the numerator and a base in the denominator, so I can actually simplify this some more. Right, so that's the same as saying z equals z to the 6 minus 3, right, because I have 6 in the numerator, 3 in the denominator, all over 2 to the 3rd, x to the 9th, y to the 3rd. And now I can simplify it completely, right? So I have z to the 3rd, 6 minus 3 is 3. And then 2 to the 3rd is 8. 2 times 2 times 2 gives me 8. X to the 9th, y to the 3rd. Now that's my final answer. I have no negative exponents in my answer, so I'm good.